understanding the decisions that parents make about investing in education is an important aspect of the economics of gender in developing countries. And we're going to quickly go through three models of educational choice that parents may make. So in the first, simplest model, we imagine that parents are choosing levels of schooling, XB for boys, XG for girls, to maximize their utility. The parent's utility, that is. The parent's utility comes from consuming today and consuming tomorrow. Their consumption today depends on whether their kids are going to be working for them. So we're imagining a rural setting where kids are economically valuable actors. Kids' value of work is W. They have time that they can be working, and the time that they're working is maximized when they're not going to school. When they are going to school, given by XG or XB, XG for girls, XB for boys, they're spending less time working, so the parents have less consumption in the first period. But schooling yields a return. We define that return by the function YB, which is a function of XB, how much time the boys in school, and YG, the girls return to schooling, which is a function of how much time the girls are spending in school, XG. Now, these functions might look like this. So we have the YG function for girls and the YB function for boys. They may look exactly the same. They may look different, as I've drawn them here. In this case, even if girls and boys have exactly the same schooling, the way that the functions have been defined is the return to schooling, the wage or income to the boy from a given amount of schooling will be higher. So there's a gap between the return to the boys and the return to girls. Moreover, at this level of schooling, the marginal return, so the slope of the return function is the marginal return to schooling. The way I've drawn it here, the marginal return to schooling is higher for boys than it is for girls when they have the same amount of schooling. So the returns to schooling might well vary by gender. So we go back to our original problem, and we put in the definition of C1 in here, and the definition of Y in the second part. So the utility depends on your consumption today and tomorrow. Imagine the first period and the second period for the adults of the family. To solve this function, this maximization problem, we take the derivative of the utility with respect to the amount of time boys are spending in school and the amount of time girls are spending in school. We set each one of those equal to 0, and then we see what that gives us. We take the derivative for the utility function with respect to girls schooling, set that equal to 0, derivative with respect to boys schooling, set that equal to 0. Now we have two equations with two unknowns, xg and xb. A little bit of manipulation tells us that that means that the marginal product of extra schooling for the girl will have to be equal to the marginal product of extra schooling for the boy, which means if we assume that they have the same return function, which notice here I slyly put that in there so that they have the same return function here, which could well be different, but if they do have the same return function, then the parent has to have the same amount of schooling for the girls and boys as the way to maximize. Wouldn't have differential amounts of school, because if the returns functions are the same, then and they have diminishing marginal returns, then there would be no point to giving extra school to one person, because then the marginal product of the marginal return to school for that person with the extra schooling would be lower than the marginal return for the person that has less schooling. A second model that we might consider is when parents care about the returns from investments in children, and in particular they care about whether they're going to be able to recoup the returns to investing in girls. And the reason that might be a particular issue in some societies is that they may have norms that girls move away when they marry. That is, the marriage norm might be of viri locality, where the daughter, the bride, moves to the town of the groom, as opposed to uxori locality, where the groom moves to the family of the bride. In these places, we often confront people saying that there's no point to investing in a girl because the girl is just going to move away. So we might think then that parents care about how they might be compensated for investments in their daughters. That is, maybe they'll get a higher bride wealth payment for their daughter. Maybe their daughter will make a larger transfer if the parents are old or sick. And then, of course, the opportunity cost of investing in the daughter is the return that one gets from the parents get from investing in sons. So we imagine again the utility to the parents comes from their first period consumption. And then the utility that they'll get from the possible transfers that they'll get in the future. Those transfers, we might further break them down and represent them mathematically. Those transfers depend on norms about marriage and how much bride wealth is to be paid. So we have some kind of bride wealth function that depends on the investment that's made in the daughter. The returns to the parents might depend on the transfers, so we might have a transfer function that depends again on the investment made in the daughter, then depends on the norms of viri locality that might be present, how far is the daughter likely to move away, and might depend on the norms about how much daughters need to take care of their parents. Then finally, we have the opportunity cost of investing in daughters is investing in sons. So the budget constraint for the parents is that whatever income they have available now, they can either consume it, invest in their sons, or invest in their daughters. So when we go through that maximization process, we end up with a function where the investment in daughters depends on how much the parents have. Obviously, if they're not really constrained because they're wealthy, then parents will invest a lot in daughters. But it also depends on the norms of marriage, the norms of viri locality, and the norms of transfers when the parents are elderly. So we can see that parental investment in daughters might be very complex, might depend on a lot of expectations about what norms are in the society and the likelihood that a daughter is going to respect those norms. All of those kinds of things would come and play into just how much a parent might be willing to invest in the child. Finally, we have our third model, where now we imagine situations where we have strong social norms against sending daughters to school, so that we might imagine that those norms and the effect of those norms depend on the effectiveness themselves of the norms. That is, if nobody's respecting the norms, then there are no consequences to violating the norms. But if everybody's respecting the norms, then there are significant psychic costs or even sanctions for violating the norms. So imagine that when here on the x-axis we have peers enrolled, we imagine a situation where very few girls are enrolled in school. If that's the case, then the cost to the parent of sending their own daughter to school might be very high because they'll be ostracized or ridiculed, whereas the benefits to schooling may just be here. So the costs are exceeding the benefits, and so parents decide not to send their children to school. So that equilibrium then remains in some sense a stable equilibrium with very low levels of schooling, or maybe even moves back and fewer girls go to school. If, however, for some reason there's some push that gets a lot of girls in school, once you have a lot of girls in school, the benefits don't go down very much. But the costs decline rapidly because now nobody's going to sanction you for sending your daughter to school when everybody else's daughter is going to school. So at that point, the benefits exceed the cost, and society moves quickly to having 100% girl enrollment or equal girl enrollment to boy enrollment. So it's a simple kind of tipping point model of how social norms might prevent girls going to school, but at some point might enable girls going to school as the social norm breaks down.